Light is an amazing phenomenon. It travels incredibly fast and can pass through different materials. Sometimes when light travels from one material to another, something interesting happens. It changes direction. This bending of light is called refraction. Refraction is a fundamental concept in physics. Imagine you are looking at a straw in a glass of water. The straw appears to be broken at the water's surface. This optical illusion occurs because of refraction. Light travels slower in water than in air. This difference in speed causes the light to bend as it crosses the boundary between the two mediums. Refraction is a common occurrence. We see it every day. Understanding refraction helps us understand how lenses work in glasses and cameras. It also explains why we see rainbows after a rainstorm. When light travels from a less dense medium to a denser medium, it bends towards the normal. The normal is an imaginary line perpendicular to the surface at the point where the light enters. For example, when light travels from air to water, it slows down and bends towards the normal. This bending is because the water is denser than the air. Conversely, when light travels from a denser medium to a less dense medium, it bends away from the normal. For instance, when light travels from water to air, it speeds up and bends away from the normal. This bending is because the air is less dense than the water. The amount of bending depends on the angle at which the light hits the surface. It also depends on the refractive indices of the two mediums. The refractive index is a measure of how much a material can bend light. Snell's law is a mathematical formula that describes the relationship between the angle of incidence and the angle of refraction. It states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is equal to the ratio of the refractive indices of the two mediums. Snell's law is written as n1 equal sign and 2 2, where n1 is the refractive index of the first medium, Th1 is the angle of incidence, n2 is the refractive index of the second medium, Tha2 is the angle of refraction. Let's take an example. If light travels from air, refractive index equal sign 1, to water, refractive index equal sign 1.33, at an angle of incidence of 30 degrees, we can use Snell's law to calculate the angle of refraction. Using Snell's law, 1 times sin, 30 degrees, equals 1.33 times sin, 32. Solving for 32, we get an angle of refraction of approximately 22 degrees. This means the light bends towards the normal by 8 degrees. Refraction plays a crucial role in our everyday lives. Understanding refraction is essential in many fields including optics, medicine, and astronomy. 1. Eyeglasses and contact lenses. Refraction is the principle behind corrective lenses. Eyeglasses and contact lenses use refraction to bend incoming light rays. This ensures that the light focuses correctly on the retina, providing clear vision. 1. Microscopes and telescopes. These scientific instruments use lenses to magnify distant or small objects. Refraction allows microscopes to reveal the intricate details of tiny structures. Telescopes use refraction to observe celestial objects in the vast universe. 1. Fiber optics. Refraction is crucial in fiber optic cables. These cables transmit data as light pulses. The light stays within the fiber due to total internal reflection, a phenomenon caused by refraction. 1. Rainbows. Refraction is responsible for the mesmerizing beauty of rainbows. When sunlight passes through raindrops, it is refracted and reflected internally. This process separates the different colors of light, creating the arc of colors we see in a rainbow. As we have explored, refraction is a fascinating phenomenon that governs the behavior of light as it travels through different mediums. It underpins numerous technologies and natural wonders, making it a fundamental concept in our understanding of the world around us.